Welcome to class of physics. In previous sections, we completed two parts of this same unit. So one is multivibrators and another one is integrated circuits. Now we are going to go for the third part, that is operational amplifiers. Okay. So what is the operational amplifier? Why this operational amplifier is designed? Let's see first. Here, the discrete transistor amplifiers are having limited gains and bandwidth. For the higher gains, we should require multi-stage amplifiers. But the design of such multi-stage amplifier becomes complicated as the required gain and bandwidth have to be increased. So interstage coupling becomes critical in such kind of circuits. A distinct approach have to be made. So that discrete approach leads to the fabrication of operational amplifiers. That is simple. For higher gain, we required multi-stage transistor amplifiers, but that is difficult to make the connections or make the coupling circuits. That's why there is a development leads to operational amplifiers. These operational amplifiers are in terms of integrated circuits. Okay. Then what is operational amplifier? An operational amplifier is basically multi-stage high gain direct coupled amplifier with two differential inputs and a single-ended output, and which uses feedback to control its overall response characteristics. It may be used to perform numerous linear operations and some non-linear operations. Okay. Integrated this op-amp means simple. It's basically multi-stage high gain direct coupled amplifier with two differential input and single-ended output. So next, why we call this as operational amplifiers rather than only amplifier? Okay, the operational amplifier is a versatile device used to amplify DC as well as AC signals and was originally designed for computing mathematical functions like addition, subtraction, differentiation and integrations. Hence the name operational amplifier and abbreviated as op-amp. Okay. So it is a versatile device used to amplify both DC as well as AC signal. By using operational amplifier or op-amp, we can amplify both DC as well as AC signals, and it was originally designed for computing mathematical functions like addition, subtraction, diffraction and integrations. Actually the basic concept to fabricate these operational amplifier is for mathematical computation. In World War II they required such kind of operations or to draw the trajectories. So for that purpose they prepared these operational amplifiers. So these operational amplifiers works mathematical functions like addition, subtraction, differentiation and integrations. So due to this kind of operations they call this as operational amplifier and abbreviated as op-amp. Okay. So this is the basic of concept of op-amp. Now let's see what are the symbols and what are the operational amplifier symbol. The circuit symbol of op-amp is basically the standard triangle symbol for an amplifier. Main connections such as inverting, that indicates negative, and non-inverting inputs and outputs are shown here. The standard circuit, main part of the circuit, is represented by the triangle. So this is the symbol of op-amp and it has three terminals. One is non-inverting terminal, so that is for positive, and inverting terminal, that is represented by negative, and one output, so that is V out. It has two input terminals and one output terminals, and these two are plus VCC and minus VCC. These represents for power supply to the operational amplifier. You may represent in symbol or you may not. Okay. That is no problem, but we should represent at least input and output, plus, minus and V out. This positive terminal input that we call it as non-inverting and inverting terminal, and negative input terminal we call it as inverting terminals, and one is output. So this is representation of operational amplifier. Next, polarity conventions. That means What does the sign indicates here? Polarity of op-amp. Input terminals have been marked with minus and plus signs. These are meant to indicate the inverting and non-inverting terminals only. It simply means that a signal applied at negative input terminal will appear amplified but phase inverted at the output terminal. Similarly, the signal applied to the positive input terminal will appear amplified and phase at the output. Obviously, these plus and minus polarities indicate the phase reversal only. So this is symbol of op-amp. There are two terminals, one is positive and negative, and one is output. Here positive terminal we call it as non-inverting terminal, negative terminal we call it as inverting terminal, and here the output. The main thing of op-amp is amplify. It will amplify. How it will amplify? Suppose we are going to provide a signal. So this is a signal at non-inverting terminal. Then its output will be amplified signals of the same phase. See here, so it starts from here and like this side. The same signal is at the output, but it is amplified. The amplitude is amplified. Suppose if you provide the input signal to the inverting terminal, so then what happens? The same signal I am applying here now, the sine wave. Now the output will be out of phase. That means phase reversal. It will give the 180 phase shift, so that we will get the output amplified and phase reversal. See here. So this is like this. This output is inverted and we get amplified signal. So this is the polarity conventions, and sometimes we represent this by P1 and P2. Okay, P1 and P1 and P2. So this P1 P2 indicates the input signal at terminal 1 and 2, and there should not be any necessary condition that V1 should be negative voltage and V2 should be positive voltage. Okay, only this represents the convention, whether it is inverting terminal or non-inverting terminals. We may provide any voltage to this. You can ground this, or you can ground this also. This plus minus not indicates the positive terminal should be connected with this terminal only and negative terminal connected to this terminal only. That is not the meaning. Okay. This is about polarity convention of op-amp. Next, block diagram of op-amp. So one such kind of operation amplifier is 741. Its operation block diagram is representing here. Operational block diagram. It has 4 stages. So these two are the non-inverting input and inverting inputs. The first block diagram, 1 2 3 4 stages. First one is input stage, second one is intermediate stage, and level shifting stage, and one more is output stage. So these are the 4 steps in block diagrams. What is input stage? The input stage is a dual input balanced output differential amplifier. The two amplifiers are applied at inverting or non-inverting terminal. This stage provides most of the voltage gain of the op-amp and decides the input resistance value R1. So the main thing is, it is dual input balanced output differential amplifier. Now we are going to provide 2 inputs here, and the output is balanced outputs. These outputs are fed to the intermediate stage, the operation amplifier itself. Intermediate stage. This is usually another differential amplifier. It is driven by output of the input stage. This stage is dual input unbalanced out differential amplifier. This stage provides additional voltage gain to the input signals. Okay. Now already there is a gain in this input stage, although this intermediate stage will add additional gain to this output of the input stage. And the third stage is level shifting stage. This is the third stage in the block diagram of op-amp. Due to direct coupling between the first 2 stages, the input of level shifting stage is an amplifying system with non-zero DC levels. Actually what happens in level shifting, in these two steps the output from this will be at the higher state. Now this level shifting will bring this potential to the ground level, so DC level to 0 volt with respect to the ground. The last step is output stage. This is normally complementary output stage. It is increases magnitude of the voltage and raises the current supplying capacity of the op amp. It is also provides low output resistance. The output stage is push or pull to transistors. This is the block diagram of IC741. In our syllabus they have not mentioned this syllabus or this part block diagram, but also this is a little bit important concept. So next one is ideal characteristics of op amp. This is important. What it means ideal? Ideal means a perfect amplifier. Actually these are not practical results. These are the assumed results or considered to be a perfect one, but practically these values mean to be different. Okay, the first one is op amp has infinite voltage gain. The gain of the op amp is infinitely high, so that we call it as infinite. Second one is infinite input resistance, so that the almost any signal source can be drive it and there is no loading of the preceding stage. So one is infinite voltage gain and the second one is infinite input resistance, and the third one is zero output resistance. Zero output resistance, so that the output can be drive an infinite number of other devices. Perfect balance, the differential voltage in inverting and non-inverting terminal be 0. And fifth one is zero output voltage when the input is 0. Okay. In differential amplifier we can study this easily. There is a differential amplifier and this is output. Here we are providing two inputs V1 and V2 and this is Vout. Always the output will be the gain times the difference between these two. Suppose here we are providing 5 volt and here 0 volt, then the output is difference of these two into gain. Gain, if you take A as a gain, then the difference between these two voltages is now 5. So this is the output. Suppose in case we are applying both same voltage at both the terminal, here also 5 volt, here also 5 volt, the difference is now 0. For that the output should be 0. This is the ideal characteristics of the operational amplifier. Infinite bandwidth, so that any frequency signal from 0 to infinity can be amplified without attenuation. In ideal characteristics there is no attenuations. We can amplify any range of bandwidth from 0 to infinite frequency range. Infinite common mode rejection ratio, so that the output common mode is noise voltage is 0, rejection ratio is 0. Infinitely slew rate, so that the output voltage changes occur simultaneously with input voltage. Zero drift characteristics of with temperature. So these op amps are work at maximum all the temperatures without any change in its characteristics. Okay. These are the ideal characteristics. So these terms we will study in next classes. Now I am not going to explain all these here only. Okay, so take the screenshot of this one and note down. Next one is equivalent circuit of an op amp. Here the equivalent circuit. This equivalent circuit is drawn based on the characteristics of ideal op amp and practical op amp. Usually the op amp is represented by a triangle and two input terminals, one output terminal. So this we call as schematic symbol. Okay. Here it is plus, minus, or V1, V2. Here it is output, and these are the plus VCC and minus VCC. Okay. So this is schematic representation. But what is the equivalent circuit of the op amp? Here two circuits are representing. One is ideal op amp and then is practical op amp. In ideal op amp, we studied a characteristics. One of the characteristic as the input resistance is infinite and the zero output resistance. Input resistance is infinite. For that, here we are representing these two are the input terminals. Here there is a breakout. There is no connection between. That indicates there is a input infinite resistance. But in practical case it is different. In practical case we cannot create a infinite resistance, but also there is small amount high resistance, not small, there is a high resistance is there. So for that we are representing by resistor here. So this in ideal case there is no any such kind of resistors, that indicates it is infinite resistance. But in practical op amp we are representing by a resistors that represents a high resistor. Next, output zero resistance. For that there is no any resistor here. Okay, there is simply a circuit. Okay, short circuit is there, that indicates there is a zero resistance. So this is the ideal case. But in practical op amp, so this is not the case. In practical op amp we have a small amount of resistance at the output. For that representing by a resistor here. This resistance is very small, but not zero. And then gain. So gain is V in into A. So V in means what are the voltage applied to the input terminal into the gain of the amplifier. So that will give the output voltage. In case of practical op amp, the same thing. Here the input is differential input. The difference between these two input terminal voltages into gain times A. So for that it is A V2 minus V1. So this is the output. Okay. So these are the equivalent circuit of op amps. Okay. For this I will stop the class. Next we are going to study about different cases of operational amplifiers as open loop, closed loop, inverting, non-inverting and differential amplifiers. Okay. Now take the assignment. Draw the equivalent circuit of op amp and write the ideal characteristics of the op amp. Thank you.